to go into a little bit more depth on equilibrium, but we're going to focus on the case when you have a 2D system of forces. So only all the forces are within the same plane. All right. So in this case, we know that there's going to be, we're going to assume that there's no force in the z direction. All right. So in that case, we know that at equilibrium, the sum of all of our forces acting on a particle must be equal to 0. All right? If all of our forces are in the 2D plane, what we can say is that the sum of all of the x components of all of our forces plus the sum times the unit vector I plus the sum of all the y components of our forces times vector j must also be equal to 0. All right? So we know that sigma fx must be equal to 0 and sigma fy must be equal to 0 for a particle to be in equilibrium. Alright, so we can solve for, because we have two equations, alright, we can solve for up to two unknowns, unknown forces, or directions, I should include, may be determined using these two equations. All right. So to apply these equilibrium equations, what we're going to do is we're going to follow this simple analysis procedure. So the first thing we're going to do is we're going to define our free body diagram. So we're going to define the xy coordinate system. So pick a system that's convenient for you. So make your life easier. So don't do the least amount of trigonometry you have to do. So pick a good coordinate system. All right. So you're going to define the x-axis and the y-axis. All right. So once you do that, you're going to label all the forces, both the known forces and the unknown forces on the diagram. And then for the unknown forces, you're going to assume a direction for those forces. So they're going to be going up. Is that force going up? Is that force going down? Is it going to the right? Is it going to the left? You're just going to make an assumption for that unknown force. And later on, you're going to solve for that force, so you'll be able to determine it no matter what. All right. So the second thing you're going to do is if you're going to apply once you have your free body diagram, you're going to apply the equations of equilibrium. So you apply all the sum of the forces in the x, all the sum of the forces in the y, to find the unknown magnitude of your force and the angles. So you remember that if that forces are considered positive, they act along positive axes. Obviously, if forces are negative, they're considered negative, they're acting on the negative axes. Sometimes there may be cases in 2D if you have greater than two unknowns, but there's also a spring that's present. You can apply the additional relationship that force is equal to k delta s to help solve for an additional unknown. So you have to make sure that the number of equations equals the number of unknowns. Otherwise, you can't solve the problem. All right. And then the last thing is that you may solve the problem, you may obtain a negative magnitude for an unknown force. If that's the case, the true direction of the force is opposite of how you drew it on the free body diagram. All right. So that's the procedure we're going to follow to solve the next couple of example problems for when you have a particle in equilibrium in 2 dimensions.